Hi all, this is Mr. Yeager again for physics. I'm going to start off by looking at a couple more tension problems, and then we're going to look at forces, 2D forces, where we're pulling an object along the ground either by pulling upwards a little bit or pushing down on it some. So let's start off with these two tension problems. I got one right here. All right, so this goes back to the prior video you just looked at. So if you have any issues, you can keep on looking at some of these. This is just to help you understand how to do more of these problems. All right. So we have this 50 Newton object being hung by two wires. One's at a 70-degree angle, one is at a 26.6-degree angle. And it gives us the tension of that wire, of the wire A, 45 newtons. And it says basically we want to solve for everything related to wire B. So draw out your free body diagram. We have a 70-degree angle wire, wire A, which has a tension of 45 newtons. And then wire B is at a 26.6-degree angle, all right? And then we have weight. The weight of the object, it gives it to us, is 50 newtons. 50 newtons, just right away, don't have to solve for it. So what do we need to think about here? I need to try to find everything about B. I only have the angle. In order to find other parts, I need at least one other part, all right? So what can I do? Well, probably what I can do is I'm going to play around with this triangle right here. I'm going to find the two components for it. The TAY and the TAX, all right? And so if I solve for TAX is going to be 45 times the cosine of 70, sorry, and TAY will be 45 times the sine of 70. So if I do those two numbers quickly, times TAX comes out to basically about 15 newtons. TAY comes out to about 42 newtons. Okay? And so, what does that tell me? Well, I need to think back to my rules. What do I know about the x components? What do I know about the TAX and TBX? Well, they're going to be equal. And those are the only two forces, so they're equal to each other. So TBX is actually equal to 15 newtons. Done. Now with that, you could use the angle and solve for the rest of them, but I'm going to go a different way. I'm going to use TAY because I want to relate it to the weight. Well, weight equals TAY plus TBY. And if the weight is 50 newtons and TAY is 42, what needs to be added to that? Well, TBY must be 8 newtons. So TBY is 8 newtons. And so that leads me to finding the tension, which I can use Pythagorean theorem for, or trig, and it tells me that this comes out to 17 newtons. I did Pythagorean theorem, 15 squared plus 8 squared equals TB squared, and then take the square root. The thing is, you can go ahead and try out the 26.6 as well. If I try the 26.6, it might be a little bit farther off, okay, and it is. It does come off a little bit, but that's it's going to basically be fairly similar, okay, with it. So. Okay. Oop, I'm doing something wrong. Sorry. Oh, no, it comes in close. I just did it with the cosine. If I did cosine of 26.6 equals 15 over TBX, or TB, the hypotenuse, TB comes out to basically 17 newtons, rounded up. Okay. So you might see some discrepancy there. That's again because we are rounding, but it should all still come out to be the same. All right. If we do one more problem, all right, we have this object hanging in the middle of a wire, causes the wire to bend equally on both sides. That is very important to notice, equally on both sides. So, I have two tensions again, T, I'm going to call it T1 and T2, and weight going down, weight's going to be 46.5 times 10, 465 newtons. 465 newtons. All right, it wants me to try to find the angle. Well, the thing is, if it's bending down equally, these angles are equal. So I only need to solve for one of them. I don't need to solve for two. They're going to be equal. So let's go ahead and draw out my triangle nicely here. I know that the wire has a tension of 625 newtons. So I have that. The weight is 465. If the angles are equal, the TY components are going to equal half of the weight. So if I do 465 divided by 2, all right, that gives me 232.5 newtons. So that's the y component. And then from there, I just show off some trig skills. I'm doing sine. I'm going to do inverse sine. Inverse sine of 232.5 over 625 gives me an angle of about 22 degrees. That's what's going to be the angle on both sides. So that's just a quick review of tension. What I want to go into now is another pretty quick topic. All right. What if we have a problem where we are pulling the object across the surface? We're going to primarily look at horizontal surfaces, and we're pulling at an angle. What if I apply a force at an angle for this? All right. What do you think we got to do with that force? Okay. Let's just assume, let's make up some problem. Let's say that it's a 5 kilogram box pulled with a 20 Newton force at 30 degrees above the horizontal on a frictionless surface. Okay? So, if I'm given that problem, I basically have to draw this particular free body diagram. An angled force, okay, I usually draw that coming from the side or from a corner, 30 degrees, okay? We're saying this is 20 newtons. What other forces are acting on this box? Well, we still got weight and we still got normal. No friction this time. We really don't need to treat this any more special than we have with any other problem. The only thing that we see new here is, all right, this object we said is being slid across the ground. So it's sliding straight across the ground. So this is the direction of the acceleration, all right? Which means I don't want to use this force in the formula. I don't want to use Fa in the F net formula going back to last unit. Remember, F net equals m times A, which equals the sum of the forces, all right? What is creating the acceleration? It would only be a component of that force. So I would split this Fa up into two parts, Fax and Fay. All right? I'd split up the components of it. All right? Because now I can clearly see this object is sliding straight to the right. It's Fax that is creating the net force. That is what we're looking at. That's what we're playing with here. All right? And so I'm going to go to a new page. Let's go ahead and redraw this again. Okay. Normal, 20 newtons. I think I said it was 5 kilograms. Yep, 5 kilograms. Okay. So what if I wanted to solve for everything like you had to do in the last unit? What if I wanted to solve for, in this case, now I have to solve for Fax and Fay, but now I need to get the weight, the normal, the frictional force is 0, so I'm going to ignore that, but the net force and the acceleration of the object. Okay, this is things that we did last time. The only two new things are the components. All right, so let's go ahead and solve for everything. Let's find the two components first. All right, is that what I have to solve for first? No, but I'm going to do it that way. So the Fax is going to be the cosine component, so this is going to be 20 cosine of 30. Fay is going to be 20 sine of 30. All right. Again, if you go back and just do your trig, you understand that. For the Fax is 17.3 newtons. The Fay is going to be 10 newtons. Okay, 10 newtons. So I have two answers here, 17.3 newtons and 10 newtons. Weight is easy. M times G, 5 times 10, 50 newtons. Now this is a new thing. This is part of why this is maybe a little bit more difficult. The normal does not equal the weight anymore on this. The normal does not equal the weight. Do you notice why? Hint, hint, why? There are two upward forces now. These two forces are equal to the downward force because the box is not moving up or down, so it is at equilibrium, 0 net force in the y direction. So this means weight will equal the normal plus the Fay. Well, I know what the weight is. The weight is 50 newtons equals normal plus 10. So the normal force is actually going to become less. the normal force decreases when I pull upwards. All right? In this situation, you can always say normal will be less than the weight. That is very, very true. Okay, worth remembering. All right? So the normal force is only 40 newtons, not 50. Net force is going to equal the FAX because that's the only force making it accelerate, so 17.3 newtons. And then I do F net equals MA, 17.3 equals 5 times A. This will equal 3.46. 3.46. Okay. All right, so that's it. The big thing you see here is we got to resolve the vector, change it into x and y components, and the other part, recognize the normal is no longer the same as the weight. So let's do one more problem. What if I am pushing a lawnmower or a grocery cart, pushing a, we'll say 30 kilogram lawnmower, a constant speed, with a force of, I don't know, let's choose 100 newtons. All right. At a 60-degree angle. At a 60-degree angle. I'm going to leave it at that. Basically solve for everything. I want to know what FAX is, FAY. I want to know what weight is, normal. This one I'm going to say there is friction, so what's the coefficient of friction as well? What's the net force and what's the A? All right, so the first step, let's draw the free body diagram. All right, you're pushing a lawnmower, so I don't tell you which way the angle is because this should be self-explanatory. How are you going to push that lawnmower? You're going to push it down at an angle, so there should be a downward applied force at an angle. All right, what are the forces acting on this? Weight, normal, and frictional force. Okay? So let's see how this all comes out. What can you solve for? Well, there's something else that we should notice pretty quickly. You're moving at a constant speed. What does that mean? It means acceleration is 0. It means net force is 0. Okay? The net force should be 0. So again, it's your choice on how to approach this. You can solve for the weight right away. 30 times 10, 300 newtons. Okay, the weight is 300 newtons. All right, so now we probably have to start actually doing a little bit of math here. We got to solve some of this stuff. So I go ahead and draw out the rest of this triangle. I can't use that FA. The FA is not opposite the FF, but a component of FA, FAX is. There's FAY, 60 degrees. And so I can solve for both of these. FA, I said, was 100 newtons. Okay, so this would be 100 cosine of 60. And this would be 100 sine of 60. This is pretty much always true. You can pretty much say the x component will always be cosine and y will be sine. So if I do this, this equals 50 newtons. And that equals 87. So 87 newtons for the normal. Oh, whoa, what am I doing? That's not where I wanted to put that number. 87 newtons for FAY, 50 newtons for FAX. All right. Well, what else do I know? If it's moving at a constant speed, FAX must equal FF, so this will equal 50. There's no net force. So the frictional force is 50 newtons. So that leaves me just with the normal and the mu, and obviously I need the normal to solve for mu. Mu is frictional force over normal, so I need to solve for normal. Well, in this case, what do you see happen? Is the normal going to be greater or less than the weight, or equal to it? Well, it's not going to be equal. You have that extra force down. This will be normal equals weight plus FAY, because you're pushing down, so the normal force is going to increase. So I add the weight and the FAY together. So 300 plus 87, 387 newtons is the normal force, 387 newtons. And now I can solve for mu. 50 over 387 is 0.13 newton. Okay. So that is all you're looking at for these particular problems, which again, you have some more to practice with it. All right. Obviously recognize which way is the angle going. Are you pushing down on it, or are you sometimes pulling up? Okay. Obviously the problem should be pretty clear with that. In these problems where you push down, the normal will be greater than the weight always. When you pull up, the normal will be less than the weight. All right. So be careful with that. That's usually one of the big problems. Other than that, there really wasn't anything too new that I introduced to you. All we did was resolve a vector like we've done for velocity, all right, or with tension. So it's really pretty straightforward based on what you've already did from last unit. All right, that's it. Thank you.